All right, welcome to the first video. So these videos just go through the notes. They don't go through the homework, but they give you all the content you'll need in case you've missed class or would like a refresher. Okay, so this table just goes over some of the basic vocab. So a point indicates a location. It has no size. To name it, we use, hold on one second, make sure this is working. To name it, we just use a capital letter and we just draw a dot and we call that a point. So a dot with a capital letter. And aloud, we would say just point A or point B. Okay? So something like that. Okay? And that's our diagram. Okay? So a line, you have two ways to do it. You could say line AB, or you could say line L. This is a cursive L. Any cursive letter will do. And of course, this is going to be read line AB. Okay. And it's easy to remember because there's a line symbol on top of it. So an example of a line, we could just write that, or we could put some points on there, and we need 2 points to make a line, so we would just call that line AB. Right. A plane, we have some choices here. We could just call it plane AB, C. So a plane's going to take 3 points. You can also use a bold capital letter. So something like P, like this. That'd be plain P, or just P. Picture. So one thing you want to note is that these points have to be, they can't be in a line, or else there could be multiple planes that have those same 3 points. So we call this is non-collinear, meaning that if you connect the dots, it makes a triangle. And that triangle is also a plane, right? It's a flat kind of connection piece there. If it makes a line, like if we add point Z in here, that is not a good name for a plane, for one, because it's a line, and also because there could be other planes like this one that goes up and down through it, so it wouldn't be descriptive enough. So that's kind of why we need, can't be in the straight line, and you need 3 of them to be a plane. Okay. A segment, we just, the same as a line, but we don't have those arrows on it. We could just say segment AB, and that's pretty easy to draw too. You can probably guess what it's going to look like. Something like this. Okay. Array is a half line. So it's the exact same thing as this segment. We'll just copy and paste it. But it does go on infinitely in one direction. So you can kind of see it's like half of a line because it doesn't have arrows on both sides. And we call that ray AB. And we would write it like this. So this A is called the endpoint, and it does not have the arrow. So the order does matter here. Ray BA is something completely different. It would start at B and go through A and continue going on. But this is ray AB, starts at A. Okay. Opposite rays are 2 half lines together. They have the same endpoint and they together form a line. So let's say if I give you these 2 rays, let's draw a picture of those 2 rays in the way I want it. So C is the endpoint. It's kind of like the middle point for this. And then you have A and B. So you can see one ray, CA, and you can also see another ray, CB. And they go in opposite directions and they form a line. So those are called opposite rays. Okay. And just to kind of set the stage here, for some of the most basic facts in geometry. A postulate or an axiom, if you see that word, it's just an accepted statement of fact. Okay, so one of the postulates for this unit is that through any 2 points, there's exactly one line. And it's this line, right? Lines are straight. So there's only one way to draw that. You know, if we drew this, that's not a line, okay? And if you straighten out all those other paths, you end up just getting that same line, line AB, okay? So there's only one line that goes through A and B, and it's called line AB, or just AB with those arrows on top of it, okay? The next postulate has 2 lines, and it says if 2 distinct means different. So if 2 different lines intersect, then they intersect. Sorry, this was B. They intersect at exactly 1 point. Okay, and this is called a conditional statement. It's an if-then. So when it says if 2 distinct lines intersect, there's a lot of info that's happening there. One is that there are 2 different lines, and 2 is that those lines that we're talking about in this statement, they intersect. And if those 2 conditions are met, then we know for certain that then they intersect at exactly 1 point. And we know what point that is too. It's the point right here. So maybe like point P. Okay. A similar statement can be made about 2 planes. For example, plane P and plane R. If 2 different planes intersect, then they intersect in exactly or on exactly 1 line, and you can see it. So this is in 3 dimensions, but they both intersect on this line. Okay. And for this one, we have through any 3 non-collinear points, there is exactly 1 plane. So, and the reason why that's true is because there's only 1 triangle that connects these, and that can be like expanded out to just a plane. So you could call that plane P. Or you could call it plane DEF. There's only 1 plane DEF. Okay? But remember, it's got to be non-collinear. Because, again, if you had 3 points in a line, that you could do this plane, like flat on the screen, or you could come out of the page and do a plane like that. So 3 in a row is no good. I mean, there's more than just 2. There's like millions of different planes that go through those points. So it's got to be non-collinear. They got to form that triangle. Okay. So those are just some facts. I mean, this is the kind of language we'll be talking in this course. So let's answer these questions, and then that'll be it. So we have a diagram here. What are 2 other ways to name QT? Well, for one, you can just flip it and name it TQ. Or you could use other points that are on that line, and that line's right here. So we could use like NQ maybe. And by the way, there's more than one right answer to these, of course. Plane P has, what I can see, 4 labeled points. So as long as they are non-collinear, it's fine. So like VRS, or plane. I could not do RQS. That is a no-go because there's more than one plane that have those points on it. This plane that goes up and down through it, we don't want to talk about that plane. So we got to choose ones that don't form a line. So how about like VQS? Collinear points, so any points that are on a line. The first one I saw, the first triple was R, Q, and S. And for coplanar points, were kind of the ones that were on plane P. So, and they all are coplanar because they rest in the same plane. Segments, I spot DE, FE, or FE, or EF, and then there's the larger segment, DF. And just note that, so that's everything. And if you flip the order, it still kind of just falls under that same category. It's still the same line segment, okay? Because, it doesn't matter the order for segments or lines. Rays, the order does matter, but not for this. So these would just fall into the same group, whichever. All the rays, okay. Well, a ray has to have 2 points. So could we go, how about let's start at E, and you can go to F. And you could also start at E and go to D. So that's this ray and this ray. But there's actually 2 more because we could start at D and go that way. So it has a different endpoint. You see, so DF is actually something completely different, and FD is something completely different as well. Okay, so there's 4. And opposite rays, I would just go with the first 2 that we wrote, EF and ED. What is the intersection of plane UVR? That is going to be the front face. And XTQ, that's going to be the left side. That just helps me kind of narrow down. So I know that the front and the left are going to touch here. UQ. And even though these planes look like they stop, they don't. Planes always go on forever. Unless it said something in the problem about how it was a cube. It is still the case that these planes go on forever. And there's a problem down here where I refer to it as a cube. But maybe that's not precise. So maybe we should just call that, planes. A cube would stop, but remember, a plane goes on infinitely. So when we answer a question like this on the homework, we want to make sure we answer with a line. Okay, not a line segment. Okay, that's actually probably my mistake. It's a little unclear there. Planes intersect on lines. We know that from the postulate on the last page. Okay, which planes contain XW? Okay, well, XW is back here. And there are 2 different planes that include that line as part of it. Kind of as a little bit of a boundary of this cube or this box. It's really these 2. We have the back and we have the top. So I would go ahead and call these planes UXW and TXW. This is going to be the back and this is going to be the top. Okay. All right, and then for this one, this was just kind of a chance for the class to just list out as many things as they can about this picture. I'll just list some things just to get your mind, jogging a bit. These are collinear. You could say really anything. You could say planes R and P. So we got a little script P or bold, whichever. Notation kind of changes, but they intersect on line AB. That's a good fact. It can probably be assumed that point H does not lie on plane P. Seems fair. It could, I guess, but that would kind of be a trick question. But it's important to know that in geometry, you can never assume anything based on the picture, because this could come out like this, which those planes do go on forever. So I could be on the plane, but so you have to be a little cautious when you say things like this. But don't worry, I'm not going to try and trick you. Just in general, it's just something to look out for. And maybe one more. How about plane P could be named plane what? Well, any three non-collinear points. So you couldn't call it plane ADB, but you could call it plane ACE. Okay. All right. So that's it for the video. Thanks for watching. I'll continue to post these, so you can go ahead and watch the next one if you want to.